Hello, and welcome to Word on the Reef, a podcast where we take the plunge into one of the world's most spectacular natural wonders, the Great Barrier Reef. My guest today is Dr Kate Quigley, a molecular biologist who has spent years studying coral genetics, biology and reproduction, and in particular, what makes some corals resistant to heat stress while others are vulnerable. All this research is super important for understanding how we can help coral reefs in the face of accelerating climate change. Now, last episode, we went on a snorkeling tour at the Great Barrier Reef and learned all the basics of coral biology, which is going to be super helpful for understanding today's conversation. So if you haven't already, I highly recommend you go back and listen to it. Kate's expertise is in high demand, and she currently divides her time between James Cook University on the Great Barrier Reef in Townsville, the University of Western Australia in Perth, and the new Minderoo Exmouth Research Laboratory, located on the stunning Ningaloo Reef in Western Australia. She is Research Director at the lab, which was founded by the Minderoo Foundation, one of Australasia's largest philanthropies. But today, I'm going to be catching up with Kate out on the Great Barrier Reef. So picture yourself relaxing on our luxury catamaran once again, floating peacefully next to a beautiful tropical island with the water lapping gently at the hull. Today, we're just going to eat some canapes and dangle our feet in the water and have a chat. It's another absolutely stunning day, which we refer to as a glass out, which means the water is as flat as glass. So we can see every little detail on the fish and corals below us without even getting in the water. Welcome, Kate. Lovely to have you here today.
Lovely to be here. Thank you so much.
Before we start, I'd just like to acknowledge the traditional custodians of the sea country we've travelled through to get to the reef today, the Irukandji, Idinji and Gunganji people, and pay my respects to the elders past, present and emerging. Now, Kate, do you have a favourite place to snorkel or dive on the Great Barrier Reef?
Oof. Yes, I do. Well, two, if you'll give me two. Probably one of the most incredible, kind of like mind-blowing places was up at Great Detached. So Great Detached is a reef very far up Cape York Peninsula, so almost at the tippy top where Cape York ends. And it's an offshore reef, and it just is wild. So it's, very deep. If you could just imagine the reef kind of coming up, touching the surface, then there's just a massive drop off because you're right on the continental shelf. And just, it felt like such a wild place. And, I felt it kind of knowing it was wild, but more feeling how remote it was and how kind of on the edge, kind of the edge of the Great Barrier Reef. So that was, I'll always remember being on those reefs up there. And then I guess a little bit closer to home, up in Cairns, I think Moore Reef. So it's on, it's where the pontoon part is, but there's the exposed side of the reef. So I think they generally take tourists over around the pontoon, but there's an area there's all these little like swimways, and that I just remember feeling like, wow, this is magic, going through those swimways on Moore Reef. So those two really stick out to me when I think about the Great Barrier Reef.
I agree. Moore Reef is one of my favourites as well. I feel really lucky that I get to go and dive there on quite a regular basis. So, Kate, you've spent a lot of time looking at corals. So obviously you love them. But why should the average person care about corals?
That's a great question. So corals are so important because of everything they support. So corals and coral reefs are something that we call keystone species or foundation species. So they provide that habitat, that substrate for other organisms to live on. So they create something that we call structural complexity. When you go out to a reef, we go out to a healthy reef, one of the first things that you notice is how many nooks and crannies and caves and burrows and all that kind of complexity is put together. And it's put together by, depending on what reef you go to, hundreds of species or tens or 20 or 30 species. So, because of all that coral complexity, you get complexity in invertebrates like crays, like mantis shrimp. You get, of course, beautiful fish, lots and lots of fish diversity. You get algae and other types of marine plants growing within or next to reefs. So you get this, what we call incredible productivity. You get reefs, and when you have reefs, generally you get lots of other species. And of course, coral reefs are the backbone to many livelihoods around the world. So a lot of protein for people. Many people around the world rely principally on protein that comes from reefs for their daily needs. So incredibly important. And also tourism, going out to a healthy reef provides a lot of different economic benefits for the people who live close to the reef. So, not only does it give us this incredible biodiversity, but it really does support livelihoods. And really important, we just had a cyclone in Townsville a few weeks ago, and coral reefs are also really important for coastal protection. So they provide that buffer between all that energy that comes out of the ocean to the shore. So they really provide an also really important function for preventing erosion, slowing erosion, and when there are big storms, buffering that erosion. So lots of really incredible benefits other than just being beautiful.
Yeah, absolutely. There are so many reasons to be thankful that coral reefs exist, not least the wonder and joy and inspiration that we get from looking at them. Do you have a favorite type of coral?
Yes, I think, and I've thought about this probably a lot, especially when you're on the boat doing surface watch. Um, my favorite is something I guess would be, it's the bird's nest coral, which in scientific name is Seriatopora hystrix. And it just has this really incredible skeletal structure. It's very fine. It really does look like a bird's nest, but it's hot pink.
Wow.
It's almost like Barbie pink.
Wow.
Barbie's everywhere these days. And it really is this incredible hot pink color. And yeah, it has some weird and wacky ecology, which I can explain later if you want, but that's definitely, I think, these days my favorite coral.
So when a coral gets sick due to stress events like extreme heat waves, the coral turns white, which is a process known as coral bleaching. Now, as we can see, the reef is still absolutely beautiful, but it is under threat because climate change is warming up our oceans. We've already had 4 mass coral bleaching events since 2016, and right now it's February 2024, and the surface water on the Great Barrier Reef is about 1 degree warmer than average. So, Kate, what are your predictions for our reef over the next month or two?
Yeah, so it's, I think it's a really critical time for us to be on the reef. So it's good that, we are out here in February because this is really, I guess, the inflection point when we start to see coral bleaching happen. So just as you mentioned, we're about 1 degree warmer than average, and we are already coming off of a very warm period throughout the world. So if we look at reefs around the world, we have already had devastating coral bleaching and mortality over in the Caribbean. And I invite your viewers to go Google, for example, the kind of bleaching that occurred in Florida. It was off the charts. And that bleaching was followed by death of many, many corals. And we've been watching as we've gone into our summertime, we've been watching these temperatures creep up across the Pacific, causing bleaching, and now it's on our doorstep. So February and March are really the critical periods where it's already the warmest part of the year. And with that additional warmth, are we going to get bleaching? So it's really that combination of hot water and usually stillness, which is kind of exacerbates a lot of light. So because these tiny algae are photosynthetic, they are very sensitive to a lot of light. They're like little solar panels. So we know that there is a interaction between high heat and high light, but really it's that warming. So bleaching, usually we see those conditions start to form when the water is ticking up in terms of temperature, warmer, warmer, warmer. And as you already mentioned, we are on average in a warmer period. So it's kind of wait and watch alert level because we definitely don't want the Great Barrier Reef to bleach again. As you already mentioned, there's been 4 bleaching events since 2016. 2016 and 2017 were horrible on many, many scales. And it would be pretty devastating to see that again. So I really hope that temperatures can start to come down over the next few weeks and we can get out of this warm period with the reef unscathed.
Which species of coral are most sensitive to heat stress?
Those are something that we call staghorn corals. And those are generally the species that they grow fast. So, a 3-year-old coral could be, let's say, the size of a basketball. So they tend to die really quickly. So say some stressor comes through, they don't tend to be very good survivors, but then they come back really fast. And then you have other species. Let's take, for example, something that we call a boulder coral, and boulder as in the sense of a big rock, because it does look like a big rock. And those are species that we call Porites corals. And there's lots of different species within that group. And those corals are generally very tough. So disturbance, stressors come through, and they just seem to be able to persist. But they also grow really slow. So I guess what I've just described is 2 ends of the spectrum where you have some species, branching species, that die really fast, but come back really fast. And these boulder corals that tend to just be really resilient, but they grow really slow. And I highlight these because they have what we call different functional roles on a reef. And we really need to have to maintain and conserve species that exist at both ends of the spectrum. But these are generally the 2 groups that people tend to notice on the reef. You usually see these big, beautiful thickets of these staghorn corals. Oftentimes they're blues and purples. And then you often notice these incredibly large boulder corals. And some of these corals can be up to 300, 400, 500 years old. So I like to think of them as our old growth trees of the reef, you could say. And those generally are the things that capture people because they're so iconic when you're in the water.
Obviously, water temperatures are a lot hotter in the ocean than average. But what sort of temperatures are we talking about that can lead to coral bleaching? And is it different for different corals and for different regions? For example, I've seen on the NOAA oceanic maps, they're predicting potential severe coral bleaching down in Tasmania, and that's not part of the Great Barrier Reef, but it's still concerning to see. But the water in Tasmania, for anyone that wants to jump in and swim, would be considered freezing. So to see that there's a chance of coral bleaching there, how does that work?
Yeah. That brings up a really great point, and that is variability in different species and different locations. So we know that different species have different thresholds. So for example, those kind of branching species that we talked about earlier, their threshold, so when they start to experience their, I guess, the sickness, that's much lower. So they tend to bleach at lower thresholds, lower temperature thresholds compared to other species. And we would call those species maybe more heat tolerant species, including some of those big, massive boulder corals. So there's a lot of variation within all the hundreds of different species that we get. But then there's also really important regional variation. So if we take, for example, the Great Barrier Reef, where on average water temperatures across the full reef sit at about 26 degrees on average. But if you go to a different reef, say in the Red Sea, their on average temperatures are a few degrees higher. So because those temperatures are over long evolutionary timescales, much warmer, those corals in the Red Sea generally have a higher threshold. So, it's really important to distinguish that these different thresholds exist for different corals across the world, and indeed for different species within one reef. So there's a lot of complexity, but it also provides an opportunity for hope. And for example, on the north of the Great Barrier Reef, temperatures are generally hotter. So it sits closer to the equator. On average, you can go up, jump on a reef up there, kind of similar to where we are right now up in Cairns, and it's generally warmer than if we went down to the southern part of the Great Barrier Reef when it's generally cooler. And so what we're looking at now is, can we use natural variation in heat tolerance within one species to try to boost the tolerance in other locations? And we can do this through something called selective breeding. So if we go up to, say, Moore Reef off of Cairns, and that's a reef that is generally warmer, so they have a higher heat tolerance, and we can mix their eggs and sperm and create baby corals with the southern corals of the same species. And we can essentially help to improve the heat tolerance of these southern corals. So there's a lot of complexity when thinking about heat tolerance at different locations in different species, but it also provides a hopeful opportunity to potentially improve the heat tolerance while we get our emissions under control.
So you mentioned coral spawning, and I know you've spent quite a bit of time studying that phenomenon. Can you tell us a bit more about it?
Yes, corals, especially on a few nights after the full moon in October and November, when they undergo a big party called mass coral spawning. And it's actually one of, I think, the great wonders of the world, that you can have hundreds of species all reproducing over a relatively short time period, over a few nights, across one of the largest superorganisms on the planet. So in this case, the Great Barrier Reef. And it is absolutely incredible, the kind of synchronicity that they have. And I'll just tell you a little story. So I've had the privilege to be involved in coral spawning for about a decade. And my PhD supervisor, Professor Betty Willis, who supervised me through James Cook University in Townsville, she was actually one of the group of researchers who discovered coral spawning in the 1980s. And their team won the Eureka Award for this incredible discovery. And I remember the first time I was spawning with her, we were at Orpheus Island in the middle of the Great Barrier Reef. And she put me on watch. It was, it was my first gig. It was my first time doing coral spawning. So she was like, Kate, okay, just make sure the corals, keep an eye on them. If they start to spawn, they should spawn around 6:35 in this particular species. Come and get me when you first see the signs of spawning. And I remember thinking to myself, there's no way they're gonna spawn exactly at 6:30. This is, they're wild animals. We've brought them into the laboratory to do these experiments. How could they be so precise? But lo and behold, the moment came, and she was absolutely right. They started to spawn exactly at the time that they were predicted to spawn. And I think that really just, it blew me away. That was over 10 years ago now, and I'm still astounded. And, that is going on up and down the reef for many, many species, hundreds of species, all at the same time. So yes, they have a healthy appetite for reproduction.
Well, that's just as well if we want the reef to be able to regenerate, isn't it? But let's go back to the subject of coral bleaching briefly. What's the difference between bleached coral and dead coral?
So it's really a transition. So let's take, for example, if we got a cold. So you first kind of feel the sniffles. Everybody knows what you feel like when you're about to get the flu, for example. Start to feel a bit under the weather, and then boom, you really start to feel crook, fevers, coughing, sneezing, all of that. And in a very few circumstances, then you could actually get really, really sick. And if you're really, really sick, you could actually die. So corals, they're the same. It's the same thing. There's a process to going through, what is effectively a sickness. So corals get stressed. They start to get a little bit of bleaching. They start to lose a few cells. Maybe they start to go a bit pale. If that warming continues and the kind of doldrum conditions continue, they get really white. And so that is now the lack of symbionts in the tissues. We're actually then able to look straight through the coral tissue and see the skeleton below. And then if the warming is really bad, then that tissue actually dies. And so that animal part falls off. And that's when you get just the bare skeleton. And oftentimes it doesn't take long for filamentous algae to start to grow on it. And then it starts to get that kind of scuzzy appearance. So it's, there's a progression. Not all warming leads to death. Very severe warming often leads to death. But even if the coral bleaches, that still weakens the animal to further onslaughts. So I hope that we can start to think about coral bleaching kind of in the same way as any other diseases. There's a progression of events that can happen, but it's a sign that we essentially have a sick coral or indeed a sick reef if that warming is quite over a large area.
So how long can a coral survive in that bleached white state before it dies?
Well, that depends on a number of factors. So it depends on the species. It depends on how much stress they had undergone before. And it also depends on the temperature. So we have a metric called degree heating weeks in our field. And that really is a measure of not just how hot, but how hot for how long. So it's that accumulation of stress. And if that is, say, above 4 or 8 degree heating weeks, it's pretty bad for the coral, and it probably will lead to death. If it's much lower than that, they can come back and recover. And generally, even if they are very white, they still have some symbionts in them. So, if it cools off, if the water cools off, those symbionts can then flourish inside the coral again, and you can have recovery. But what the worrying thing is we're now seeing warming conditions that are more and more severe. So in previous bleaching events, we would see bleaching and then we would see recovery. But now we're actually starting to see just death. So it's the temperatures are so extreme and it gets warm so fast that the animal is just essentially kicking the bucket. That all those protective effects, all those different mechanisms that animals have to withstand stress, they just can't hold up compared to the level of warming that we're now getting. So, these most recent events were not just shocking because of the kind of mortality that we're getting, but also because of the extreme temperatures that cause that mortality.
Yeah, it's true. The reef is resilient and, it can have ways of recovering, but we need to also do our part to, limit global warming. Otherwise, it doesn't have enough of a chance to recover, right?
Absolutely. Absolutely. And, we think a lot about recovery. What are the mechanisms that the reef uses naturally to recover after disturbance? How much time does it need to have between disturbance in order to recover? What do we need to do to help the reef to recover and get a breather? And one of the things that is more and more apparent is that there's just not enough time anymore between events. And so we're starting to really undercut these recovery processes. So that's why we really need urgent action on climate change, because we have looked at these incredible natural systems that, as you rightly have pointed out, have a lot of ability to recover. But we're starting to tear those down as well as temperatures creep up. There's a lot of different thresholds that we need to be very careful not to cross. And one of those is recovery. So I completely agree with you the reef is resilient, the reef can recover, but there's only so much that the reef can take. And if we do not get our emissions under control, we will start to surpass these resilience and recovery mechanisms, and we'll get into a place where that recovery will not occur anymore after these disturbance events. So it should be a wake-up call to people that we really need strong action here while we have healthy wild places to protect.
What would you say are some things, like if there's people listening who want to do something to help coral reefs, even if they don't get to go diving and snorkeling on reefs all the time like we are today, what are some things that you think people can do?
Well, I think, one of the key things is to think about how you can lend your voice to making a positive change for action on climate change. Go and vote. Go and vote for ecosystems. Go and vote for protection of ecosystems, whether that be on land or in the water. Supporting your local tourism is also a great way to support the reef. Go out and enjoy the reef so that you can be a part of that national conversation about its protection. But I would say, go and use your voice in order to support strong climate change action, and then get on the reef so that you can have the benefit of enjoying if that's possible for you.
Couldn't agree more. And can you tell us a bit about the Minderoo Foundation and the work you're doing there?
Yeah, so at Minderoo Foundation, we are very fortunate to have a relatively new laboratory up at Ningaloo Reef. So oftentimes we hear a lot about the Great Barrier Reef, which is a absolute world treasure. It's a World Heritage Site. But we also have 3 other World Heritage Reefs in Australia, including Lord Howe Island, which is the most southern reef in the world, Shark Bay, which is right below Ningaloo, and then Ningaloo Reef, which is the largest fringing reef in the world. And so up in the Minderoo Exmouth Research Lab, we now have a brand new facility in which to do field work, run experiments, do molecular work in order to really start to unlock the secrets that Ningaloo Reef has. So, just like there's a lot of research and management and policy going on in the Great Barrier Reef, so too on Ningaloo. And having the lab there is just going to open up lots of different research and outreach to that really important ecosystem.
Awesome. So where can people go to find out more?
Yeah, so the Exmouth Research Lab is on Twitter. And I highly recommend that you follow along on Twitter as well as Facebook. And you can hear all about the incredible work that our researchers are doing, looking at not just corals, but also seagrasses, fish, tiger sharks, you name it. And we have a researcher who's looking at it. So yeah, jump on Twitter, follow along. If you're a researcher listening, we just opened up our expression of interest for different research projects. So we will support you in coming and doing research on the reef. So it's a really great opportunity, especially if you're a master's student or a PhD student looking to do some really important work on an incredible World Heritage Reef. So check it out and see if it's right for you.
Dr. Kate Quigley, it's been lovely to chat with you out here on the reef today. Is there anything else you'd like to share with us before we go?
Just wanted to say thank you, and let's keep talking about reef. Let's keep thinking about reefs. Being on the reef is one of the great things about being in Australia, and so good to be out here with you on a glassed out day. Thank you.
Thank you. I hope you enjoyed our interview today with Dr. Kate Quigley. If you enjoyed this tour, please subscribe and follow Word on the Reef on Instagram to get notified when it's time for our next adventure. This is a not-for-profit passion project, so if you enjoyed it, please write a review, share and tell your friends. If you'd like to get involved in action to help protect the Great Barrier Reef, visit www.fightforourreef.org.au. If you'd like to sponsor this podcast, please consider becoming a patron for as little as $5 a month over at patreon.com/Word on the Reef podcast. You'll get a shout out and the proceeds will help towards covering costs like podcast hosting, email hosting, website hosting, and so on. That's all for now. Best fishes, and see you next time.